So hello again. We're going to continue with the renal physiology. What does your kidney do for you? So now we're going to go over how urine is formed. There's 3 steps. There is the glomerular filtration, there is the tubular reabsorption, and then there is the tubular secretion. So in your first step, the glomerular filtration, this is a passive process. You don't really need, ATPs. So there are some features that the glomerular have that will help you to filtrate. The glomerular capillary have a large surface area, and the blood pressure is high enough so that you can do, osmotic gradients. And there's the filtration membrane is very permeable. And you have to know about net filtration pressure, which is the glomerular hydrostatic pressure minus the blood colloid osmotic pressure, also minus the capillary hydrostatic. So that's about 55, minus 30, minus 15 equals 10. So usually your net filtration pressure is 10. Okay, so how much can your kidneys filter? It can filter about 625 milliliters per minute max, but usually it's about 125. And what regulates this, glomerular filtration rate? Well, I'm glad you asked. It's the renal autoregulation through the, either you can dilate or you can constrict your vessels in your kidneys. And there's 2 mechanisms. You can either use myogenic, which is it's a vascular smooth muscle that will contract when it is stretched. Or you can use the tubular glomerular. That's from the macular densa. It's a negative feedback. It promotes constriction and dilation of the afferent arterioles, whereas the myogenic also in the afferent arterioles. So, and what kind of hormones controls your glomerular filtration rate? Well, I'm also glad you asked that question too. So there is the renal angiotensin. As you know, the juxtaglomerular cells secretes renin. We already learned in our other video. So you have angiotensin turns into angiotensin 1. This is done by the liver, in case you're wondering. Goes into angiotensin 2, causes vasoconstriction, the kidneys, efferent arterioles, and that increases systematic blood pressure. You're increasing adrenal cortex to release aldosterone, which increases the sodium reabsorption, and you decreases the stretch of your juxtamedullary cells, or they can be activated by your the renal release is when you decreases your juxtamedullary cells. When you have a blood pressure less than 80, your renal angiotensin system will just kick in. Or if you're activated by your macular densa cells or the sympathetic nervous system. And overall, this is a very complicated process where it can increase or decrease your glomerular filtration rates. Very confusing. But overall, the renal angiotensin increases your blood pressure, increases your sodium reabsorption. Okay, so, but what happens when your blood pressure is too high? Well, this is the case in most Americans, is where your AMPs, your atrial-natriuretic peptides, kicks in, where the mesangial cells relax, and you decrease your reabsorption of sodium, you decrease hydrogen reabsorption, you decrease ADH, aldosterone, renal angiotensin, because we know all those things will increase your blood pressure, and it'll increase blood volume, which increases glomerular filtration rates. So, now onto the sympathetic nervous system that can always regulate your glomerular filtration rate. It can override your autoregulation. Remember the 2 mechanisms, you know, the myogenic and the tubular glomerular. It'll decrease the afferent-efferent arterioles, which decreases your glomerular filtration rate and your angiotensin and aldosterone systems. So basically, if you're running away from a tiger or a bear, you don't really want to pee. Okay, so how do we measure this glomerular filtration rate? Well, you do it with renal clearance, which is equal to the volume of urine times the concentration of the particular substance divided over by the concentration of the substance in your plasma. There you go. So usually for glucose, it should be 0. For inulin or creatinine, it should be 125. For the PAH, it should be 625. And urea is 65. So good. So, now we go on to tubular reabsorption, tubular secretion. The next steps, you'll hear urine formation. So basically, tubular reabsorption, you'll reabsorb either through paracellular or through transcellular routes. And the paracellular, you have tight junctions. And usually when you use water, that's passive transport. When you use solute, I believe that may be active, but I have to check on that. So I will write either in the comments or the other sections. So yeah. Sorry, back. So transcellular is across apical membrane. It diffuses through the interstitial fluid. Okay, so there's certain substances that are not reabsorbed, all parts. Oh, also back to the paracellular is the potassium, hydrogen, anions, chloride, and bicarbonate through the electro gradient. And yeah, so the mechanism, you can either have active or passive. So active, you usually use the sodium potassium pump. You pump sodium out of the interstitial fluid, you pump potassium into the interstitial fluid. And also there's a secondary pump that works along with the sodium, so you can pump all the other things like glucose, amino acids, lactate, other cations. And there's also the passive. You either go through diffusion, facilitated diffusion, osmosis, we should know by this. Because sodium creates the electro gradient, osmotic gradient, and there's secondary active transport. Sodium is very important. And there's also aquaporins, aquaporin 1, aquaporin 2. So aquaporin 1s are mostly in the PCT and the LOH. It's naturally expressed. It's an obligatory. Sorry. Aquaporin 2s are the ends of the DCT and the collecting ducts, and it needs ADH to open up these little channels. So they're facultative. We also have the transport maximum. So basically, if you reach a renal threshold, like glucose reaches its transport maximum, there's only so many carrier proteins. You're gonna have glucose in your urine. That happens with diabetes. And we have tubular secretion. Blood goes through the filtrate, creatinine, urine, and certain drugs, excessive potassium, hydrogen, organic acid are secreted. And we'll figure out where each of them go in the next video.